Hello and welcome to my YouTube channel. Today we are going to see class 10 science 1 chapter number 2 periodic classification of elements, and this is a part 1 for the chapter. We had already studied in a standard 8th about the matter, and after that we studied about the atom is nothing but the smallest indivisible particle of the matter. After that, in a ninth standard already we studied about the different types of the elements, in which we studied about the metals, non-metals and metalloids. When we talk about the classification of the elements, periodic, later on we will discuss. Before that, classification of elements, we require a classification of elements because to study them, their properties should be classified on the basis of their property, on the basis of their characters. We should classify them, and that gives us a clear view and the upper hand in studying them in a detail. Because in a previous standard already we had said about the classification of the living organism. That already we have discussed in a lower standards like 8th and 9th. So now this time we are going to see about the classification of elements, how they are classified, how they are having a different characters, how it is moving from one element to the another element. Everything we are going to see in this particular chapter. Elements and their classification we are going to study. Dobereiner's triads we are going to study. Newlands Octave, Mendelleev's periodic table and the modern periodic table. This all we are going to study. When we talk about the classification of elements, this all started a long ago. Initially there were only 30 elements were known. In the year of around 1800s, only 30 elements were known that time. And with the pass of a time or the course of a time, the research went in this particular field, and at present we know almost around 118 elements, and these elements are just like alphabets of a English language. In English language we have a 26 alphabets, A, B, C, D till the Z, and this all 26 are combining in a different manners and forming a different words of a language. English means the entire English is made up of this 26 alphabets. Similarly, when we talk about this entire word or the almost universe, they are made up of smaller particles which we call as elements and their atoms. These elements are combining in a different combinations and forming a different compounds, and that compounds are forming a different matter. Like if I am talking about the common salt, it's made up of a sodium and chloride, the one single atom of a sodium and the single atom of a chlorine. NaCl, common salt, is made up of what? One sodium and one chlorine. This combines and forms a compound sodium chloride. So these elements, they should be studied in a detail. Now, the further their classification went through, initially the first classification given by the Dobereiner's triads. Dobereiner's triad what we are having is given by the German scientist Dobereiner. He suggested that properties of elements are related to their atomic masses. What he said, that the properties of elements means their characters, their characteristic physical and chemical properties, they are related to the mass of that particular element. Atomic mass already we have studied. Then what he did, he made a group of three elements. He made a group of three such elements having a similar chemical properties, and called them as a triads. He gave a name to them as a triads. Means what he said, that the first of all, the properties, the characteristics of the elements are related to their atomic mass. Means as the mass is changing, their character will go on changing. And after that, he made a group of 3 elements together and called them as a triads, and that's why the name to this particular classification is given as a Dobereiner's triads. He arranged 3 elements in a triad in an increasing order of atomic mass. He arranged them in a increasing order of their atomic masses, and in that what he said, the second element, you can see over here, the element 2, the mass of that, the atomic mass of that particular element will be the average of first and third. First of all, what he did, first he arranged them in an increasing order of their atomic masses, and then what he said, the central one will have the atomic mass as an average of first and third's atomic masses. Example he has taken over here as the first triad. What he gave is lithium, sodium, potassium. Here sodium is in between, so calculation, the lithium's atomic mass is a 6.9 and the potassium's is a 39.1, and then the average is calculated over here, which comes as a 23. So actual atomic mass for the sodium, when it was calculated, when it was studied, they found it's similar as a 23. Then afterward, the another triad he gave as a calcium, strontium and the barium. In that, calcium 40.1, barium as a 137.3, and the average of that is 88.7, and what they calculated later on, that was 87.6, means almost similar. Same way about the halides, that is the chlorine, bromine and iodine. In that also they found near about values, but the difference was little higher as compared to the previous ones. After that, in this particular section, the Dobereiner's triads, when the new elements came after the research or the new elements discovered, this Dobereiner triad failed to explain the triads for them, and that's why this Dobereiner triads failed in the proper classification of elements. After that, the another scientist came with a different phenomena of a classification or the different criteria for the classification, and the name for that scientist was the John Newlands. He correlated again the atomic mass of that particular elements is nothing but the factor which brings the changes in the atomic or the atom's characters, whether physical or the chemical character. In a different way, he classified this complete. What he gave, or the idea what he has taken in this, was from the notes of the music. Notes of the music in India, when we talk about the Indian music, is having a 7 notes: sa, re, ga, ma, pa, dha, ni. You can see over here, the 7 notes are there. Same way in a Western music, we have the notes, 7 notes are there: do, re, mi, fa, so, la, ti. These are Western music notes actually we are having. So on the basis of that, he classified this particular elements or the elements known that time. What he said, that we should arrange these elements in the increasing order of their atomic masses, and every eighth element, if I want to number it first, second, third, fourth, fifth, sixth, seventh, and then eighth comes in the first one, like hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, and then fluorine. So every eighth element is having a similar property as the first one. This was the Newlands Octave. He called them what? That every eighth element is having the similar property as the first one. So this was the classification of the Newlands octave. But again, what he did in this, some elements kept together, like here cobalt and nickel, and here cesium and the lanthanide. What he did, he kept them together because they were showing the similar properties, and the Newland was unable to explain this particular part, and that's why the Newlands table also failed to explain the further elements or the further classification of the elements. At the time of Newland, almost around 56 elements were known. So in that, some were kept together, some were classified according to the octaves, but still he failed to explain it in a proper manner for the higher elements. So after the failure of this, another scientist, the Russian scientist Dmitry Mendeleev, came with another classification of the elements. The Russian scientist, what he suggested, that again same way the atomic mass he considered for the classification of element. In this, or at the time of classification done by the Mendeleev, almost around 63 elements he arranged. He arranged in them proper table. You can see over here the table is given over here. Group 1, 2, 3, 4, group 1, 2, 3, 4, 5, 6, 7 and 8. 8 groups he made, and he classified again on the basis of their masses. And in that, some of the blank spaces he kept in between. You can see over here the blank spaces here in between. These blank spaces, why he kept? Because these elements were not known that time. And some weight or some mass he predicted, atomic mass he predicted, but the name was not given, like here 44, 68, 72. You can see that masses they have shown, but not the elements, because that elements were not discovered that time. That's why he kept them blank. The further molecular formula what he wrote over here, that is R2O, R2O3, it's nothing but the compounds what that elements or that group elements were making with the oxygen, that he labeled over here. Further, about the merits of Mendelev's periodic table, what the properties or what the benefits we had over the Newlands octave and the Dobin-Irons triads that they have mentioned over here, that we will see one by one. The first one, atomic masses of some elements were revised so as to give them proper place in the periodic table in accordance with their properties. For example, they have given over here is the atomic mass of the beryllium 14.09 was changed to correct value 9.4, and beryllium was placed before boron. So what he did, some of the elements atomic masses he corrected according to the research and according to the table, and given them a proper place in the periodic table. Further, second, what he is saying, that Mendeleev kept vacant places in the periodic table for elements not discovered till then. That, as already I told you in the table, he left some of the vacant spaces. And why he kept that? Because that elements were not discovered that time. 3 of these unknown elements were given the names as Eka boron, Eka aluminium and Eka silicon from the known neighbors, and their atomic masses were matched as 44, 68 and 72 respectively. Not only these elements, along with that their properties were also predicted. Later of these elements were discovered, and scandium, gallium and germanium respectively. the properties of these elements matched when they predicted by Mendelev's. Due to this success, all were convinced about this particular Mendelev's table, that this table can be considered as a proper classification of the elements when these elements were discovered, and they found that what he predicted was almost correct. You can see over here the table also they have given is about the Eka aluminium and the gallium, the actual what they found later on. He predicted atomic mass as a 68, they found as a 69.7. Density they predicted as a 5.9 and they received or they got after later on as a 5.94. Melting point he predicted as a low and they found as a 30.2, which is almost a lower value. And then formula of chloride, that is a ECl3, and they found as a GaCl3, means exactly what he predicted. Then formula of oxide also, what he predicted was correct. And then the nature of oxide, amphoteric oxide, and they actually got as a amphoteric oxide. Further, the third merit of this, there was no place reserved for noble gases in the Mendelev's original periodic table. However, when noble gases such as helium, neon, and argon were discovered towards the end of the 19th century, Mendeleev created the zero group without disturbing the original periodic table in which the noble gas were fitted very well. Means initially when he started the classifying elements in a periodic table form, that time he didn't kept any special or the extra reserved place for the noble gases. But as when they discovered about these elements like helium, neon, and argon, he placed them in a separate group without disturbing the original periodic table. So this all were the benefit of the periodic table given by the Mendeleev. But as we know that merits and demerits both run together. So there were some merits in the periodic table, along with that some demerits were also there in the Mendeleev's periodic table. So that also we will see one by one. First of all, the whole number atomic mass of the elements cobalt and nickel is the same. The atomic masses, when we will see the whole numbers about the cobalt and the nickel, they were same. Therefore, there was an ambiguity regarding their sequence in the Mendelleev's periodic table. Means then there was a confusion where to place them. If you will see in the chart, cobalt and nickel. Cobalt and nickel, they had the same atomic masses. Then where to place them? That was the ambiguity, that was the confusion in the mind of everyone, where we should place them. Same way, when we talk about the isotopes, first one we see, now the isotopes were discovered long time after Mendeleev put forth the periodic table, because at the time of a classification of Mendeleev periodic table, the isotopes were not known. So when they discovered about the isotopes, there was no spatial place for the isotope. Isotopes were discovered and have the same chemical properties but different atomic masses. A challenge was posed in placing them in a Mendeleev's periodic table, because as we know very well about the isotopes, they have the same atomic number but the different atomic mass number, and as the periodic table is based on the atomic masses, they should have a different place. So that was the another problem or the demerit of a Mendeleev's periodic table. The another one, when elements are arranged in an increasing order of atomic masses, the rise in atomic mass does not appear to be uniform. It was not possible, therefore, to predict how many elements could be discovered between two heavy elements. Because the periodic table, when we talk about the Mendelev's periodic table, in that the atomic masses were not evenly distributed or not evenly classified. means the difference between two consecutive atomic masses was not same. So it was not possible to explain or predict actually how many elements are there between two heavy elements or the two heavy atomic masses. Further is the position of hydrogen, the another important demerit of this particular periodic classification. Hydrogen shows a similarity with halogens, which was placed in a group number 7. For example, the molecular formula of hydrogen is H2, and for the halides or the halogens also we are having like Cl2, Br2, I2. In the same way, there is a similarity in the chemical properties of hydrogen and alkali metals, which were placed in a group number 1. There is a similarity in the molecular formula of the compounds of hydrogen, alkali metals like sodium and potassium, etc., formed with a chlorine and oxygen. On considering the above properties, it cannot be decided whether the correct position of a hydrogen is in a group 1 or group 7 with the halogens. So that was another demerit we had for the modern periodic table. So in this we have just talked about the three different kind of the classification. The first one, Doberainer triads, and the Newlands octave, and then the Mendelleev's periodic table. In the next part, we will go towards the modern periodic table